the second video in our series about monopoly. So in chapter 14, we discussed our definition and examples in class. In the first video, you saw me use algebra to show why in monopoly, marginal revenue is always less than price, because the monopolist, in order to sell more units, must lower their price. So each unit that they sell brings in less than the one before. And now we're going to talk about the monopoly graph in more detail, beyond just the demand curve. We're going to use the marginal cost curve to tell us how much the monopolist should produce, QM, the average total cost curve to tell us about profit. Notice this is identical to what we used marginal cost for in perfect competition to tell us the individual profit maximizing quantity, and average total cost for in perfect competition to draw the profit or loss rectangle. There's only one additional thing we need to think about in monopoly, and that is deadweight loss. There was no deadweight loss in perfect competition because the quantity produced was very efficient. It minimized average total cost in the long run, and it was setting price equal to marginal cost. Now that's going to change in monopoly. So, the first step to drawing the monopoly graph is to draw demand twice as steep as marginal revenue. The good news about this graph is there's only one panel, right? Different to perfect competition where we had the global or local market and then an individual firm. Here, if we're thinking about iPhones in 2008 still, Apple is the global market. The individual firm is the global supply. So there's no need to differentiate between global market on the left-hand side, individual firm on the right-hand side. There's one panel. The individual firm is the global market. So that's very different. We're still going to be thinking in dollars per unit because we'll have costs and price together in the same graph. And then the next big difference, besides only having one panel, is that demand is downward sloping. In a monopoly graph, the monopolist faces a downward sloping demand curve. They are not a price taker. There are substitutes for their product. Demand is not perfectly inelastic unless you can think of a complete necessity that has no available substitutes, maybe something like insulin that can only be produced by a certain drug company because they have a patent, or EpiPens if there were no generic EpiPens in the market. But for most monopolists, demand can be steep for inelastic monopoly products or flat for non-necessity monopoly products. Think about like virtual reality when it was first introduced. But demand is downward sloping. It is not perfectly elastic, right? They're no longer price takers. And then as I showed you in the last video, you want to follow up with a marginal revenue curve that's twice as steep. That should always be your first step. Draw those two together. It's like an economist gang sign, throwing in a little bit of a demand followed by a marginal revenue. Marginal revenue at every quantity other than 0 is always lower than demand. Demand is telling us about price and what we can charge. Marginal revenue is saying each unit will bring in less than that, because in order to sell additional units, you will have to lower the price on everything before. A little bit complicated. We can talk about it more in class together. The second step, just like in perfect competition, is to throw in marginal cost. So let's use a different color just to make our graph beautiful. Marginal cost was used in perfect competition to tell us how much an individual firm should produce. And it does the same thing for monopoly. They are still going to follow the golden rule, right? Golden rule was marginal cost equal to marginal revenue will give you the quantity that maximizes profit. That's where profit will be maximized. So set your marginal cost equal to marginal revenue. That happens right here. That will give you the quantity that the monopolist will produce, QM. You want to find that quantity first, just like we wanted to find QI star first in perfect competition, because everything else in our graph happens relative to that quantity. Now the next step, you don't even need to throw in another curve for this one. You want to look at the monopolist quantity. What can they charge? How much are people willing to pay for that amount of iPhones? So that's when Apple would consult their market research, tracing out your demand curve, and look at how many people were willing to buy the iPhone at different prices. We estimate that if we want to sell that quantity, people are willing to pay way up here on the demand curve. Right? The reason they want to look at the demand curve is because the demand curve tells us about consumers' willingness to pay. So it's also always going to give us the price that the company will charge. This we call the monopoly price, the price the monopolist would charge. They're going to look and say, hey, if the quantity that maximizes our profit is 10 iPhones, how much are people willing to pay if we only release 10 iPhones to market? And that is exactly how much they'll charge. Maybe it's $600. The final step is to put in average total cost. Average total cost is going to tell you whether this monopolist is making a profit. So again, all we know about average total cost is that it determines the level of profit, and its minimum is on the marginal cost curve. So you can think of a bunch of different potential average total cost curves and a bunch of potential correct answers for where average total cost is. Very different from perfect competition. Would we expect a monopolist to be making a profit? Probably. Most monopolists are not going to innovate, develop the product, bring it to market if they don't expect to make a profit. So drawing average total cost curve way up here would kind of be ding, 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 anything way up there, once we draw where the quantity crosses it, is going to lead to negative profit. And for a monopolist, unless you have a good reason to believe that they're not making a profit, we typically draw average total cost where they would be making a profit. So that means I just pick a spot on my marginal cost curve and I draw my average total cost U through there. Like I said, there's a lot of right places you could draw that. You could draw it way up here and they would still be making positive profit. You could draw it way down here. Now I'm just muddying up my perfectly beautiful graph. Just pick a spot on the marginal cost curve and draw average total cost going through that spot. Now to draw the profit rectangle, to arrive at profit, we need to think at a quantity of 10, what is average total cost? The average total cost curve U tells us what average total cost curve is, at whatever total cost is at every different quantity. So where 10 hits that curve, that tells us the average total cost at the profit maximizing level of output. That looks like something around $300. So that means Apple is charging $600 for every iPhone that costs them $300 per unit to make, and they're selling 10 of them. This is their profit rectangle. If we were going to calculate their profit algebraically, we do quantity times P minus ATC. That would be 10 times 600 minus 300, which is $3,000, right? And that was just in our classroom. So they probably made much more than that in total profit in 2008. Okay, I hope this video helps you as you walk through the steps of drawing the monopolist graph. In class together on Wednesday, we're going to start thinking about when things change in this graph and why this area right here gets the black shade of death. Why this area is dead weight loss. Where would we be in perfect competition? Where does the monopolist force us to end up? And how does that create an inefficiency? See you guys Wednesday.